Hi, in this video, I wanted to look at what you already know about radical expressions and equations. One of the things you already know how to do is to simplify square roots. And so if you were working with the quadratic formula, for an example, you sometimes had situations like this where you had the square root of negative 45. So we've kind of already talked about how that works. And if you have a square root, then the negative under the radical means you're going to have an I. And then you have to work on getting 45 broken down. So you kind of do that and you work on breaking that down. And you realize that 45 is 9 times 45 or 3 times 3 times 5. And since this was a square root, you know there's a pair of 3's. And so 3 would be outside and 5 would be underneath. But then we have the I from this negative underneath the radical, so we have to be sure to bring that down. And then we usually write it 3i square root of 5. And that would be the simplest radical form for the square root of negative 45. Now let's put a negative in front of this one. Okay, say you had negative out in front of the square root of 32. Okay, if you had that problem, then you're not going to have an I. What you're going to do is come in here and break down 32. And so you might say it's 4 times 8, and you keep going, and you wind up getting that it's 5 2's multiplied together. Okay. There's a negative, though, out in front of all of this that you have to worry about. So we have a pair of 2's and another pair of 2's. So it's going to be a negative, not an I. There's going to be a negative, and then there's a 2 coming out for those 2's, another 2 that you can take out because you have another pair, but then this guy is trapped underneath. Okay, and so this one doesn't have an I in it. It's just going to be negative 4 square root of 2. Right there should have just been a 2. Okay, negative 4 square root of 2. And that would be fully simplified. All right, now when you plug into the quadratic formula, a lot of times you got expressions that look like this, the negative b plus or minus square root of b squared minus 4ac over 2 times a, and you'd get results like that. So you had to work out the square root of 20, figure out what that was going to be. So that turns out to be a 2 square root of 5, and so now you have 6 plus or minus 2 square root of 5, all of that divided by 4. So you're going to come in and you're going to divide here by 2 because 2 is a factor of the numerator. You can factor out a 2 from 6 and from this term. And so because you can factor out a 2, 2 is a factor of all 3 spots, you're then able to simplify this. It would be 3 plus or minus the square root of 5, all divided by 2. And that would be the simplest radical form for that one. All right, now, a lot of you are going from here to here, and that continues to be okay. And you're doing it by dividing by, okay? You're doing it by dividing everywhere by 2, rather than factoring out the 2 and saying 2 goes into 6 3 times, 2 goes into 2 once, 2 goes into 4 twice. And you wind up with the same answer, you just got there a different way. So that's some of the things you've already done. Simplifying square roots. Square roots are the things that on your calculator look like this. Okay, but when you're looking at them, there really is an understood 2 inside there. It really has what's called, this right here is called the index. And so you've been dealing with square roots where the index is 2. The type of root you're dealing with is a square root. Means there's an understood 2 that would have been inside those. Okay. You've also done something else with radicals. You've solved radical equations that involve square roots. So I thought we'd look at 2 examples similar to what you've done on a previous worksheet. Okay. With these, you wind up working on getting the radical by itself if it's not already. This one's already by itself. So now you'll come in and you'll square both sides. Let me do it in the next step. You leave that just the way it was. So what you do is you come in and take what you had, and you're going to square both sides. So you're going to raise the left side to the second power, and you're going to raise the right side to the second power. Okay? So on the left, we have x squared, and on the right, we have just negative 3x plus 40, because that 2 right there undoes the square root that we have. Okay? So we get to here. Now at this point, we're going to move the 3x and the 40. So we have to add 3x, subtract 40, and you do that to both sides, don't you? So you wind up having x squared plus 3x minus 40 equals 0. So when you factor that, you wind up having a plus 8 and a minus 5, and you wind up getting 2 solutions. One of them is that x would be negative 8 coming from that factor. The other one would be x being negative 3. Okay. All right. So then here you would subtract 8, and you would get that x equals 8. And then over here, you wind up adding 5, and that gives you positive 5. So x equals 5, okay? Now, with radical equations, you must check, because you could have done everything right, but one of the answers may not work in the original. So if we check whether 8 works, we're going to plug an 8 in everywhere there is an x in the original problem, okay? And we're just going to find out, does it work? So under here, I do have a positive 64, and the positive square root of 64 is 8. It does check, so we know 8 is a solution. We know it should work. Okay, when we plug in 5 and see if it works, okay, we're going to plug it in everywhere there was an x. I'm going to plug in 5 right here, 5 right here. And this one, it turns out that both of these wind up being okay. That would be negative 15 plus 40, which is 25. And 5 does equal 25. It does check, because that's 5 does equal the positive square root of 25. So that means that one works. So your answers would be both the 5 and the 8. It's not an ordered pair. It's the solution set would be both of those, okay? All right, so that was something that you had to do with radical equations. You had to check, okay? It's a good thing, though. You'll know you're right at that point, okay? Now, this one is also a radical equation, all right? And then this one winds up working out in a similar way. It's just I wanted to remind you that if you get one like this, the radical would have to be on a side by itself. So it is. Let me do this on a new line. Okay, so it is. That means I can come in and undo the radical by squaring both sides. So I'm going to come in over here and square the left side, and over here and square the right side. Just wanted to remind you that the squaring undoes the square root, so we get the x plus 44, but that over here, don't forget that's really x plus 2 twice. So it has to be FOILed out, and you'd get x squared plus 4x plus 4. Okay, but we do have a radical, so we would want to get a 0 on one side, because we do have a square, we do have a square, so we would want to get a 0 on one side. So we'll come in and we'll make that happen. And I'm moving the x and the 44 over because I like my squared term to be positive. So do you see how now we have on this side, we have x squared plus 3x, and then happen to get a minus 40, and that would equal 0. So I wanted, on this example, I wanted to show you what would happen if over here you had two terms. I wanted you to remember you have to FOIL things out. All right, and then I just made it so it works out like this one. So from here, you would do the same thing we did on the other problem, okay? All right, and then one more example I wanted to look at is sometimes it's a lot easier than either of these. Sometimes they give you something like this. On one side, you have 3x plus 8. On the other side, you have x minus 5, both under square roots, and you're trying to solve that. So on one like that, you would undo the radicals. They're by themselves on each side. And when you square, you'd get 3x plus 8 on the left, and you'd get x minus 5 on the right. Okay. Well, this didn't turn out to be quadratic. This turned out to be linear. So be aware that sometimes they turn out to be quadratic like they did here. These were both quadratic once you got rid of the square root. This one just turns out to be linear. Okay, so we'll come in, we'll subtract x from both sides, because with linear equations, you want the x's together. Okay, so you wind up with 2x plus 8 equaling negative 5. Okay, and then you take away 8, and that winds up giving you 2x equals a negative 13, and dividing by 2, we wind up with x equaling negative 13 over 2. Okay. Okay. Now we would still have to check our answer. And so when we plug this in to do our check, we wind up on this one with 3 times a negative 13 over 2 plus 8, and we want to know if that's equal to, over here, the square root of negative 13 over 2 minus 5. And so when you check them, you wind up getting kind of a strange result, but you get the same negative number underneath on both. So it actually does make the two sides equal.